Good morning or good afternoon based on where you are. This is Dave Krahl from Imagine That. We're going to be talking about ExtendSim and a hierarchy today in our master class. This is a part of our ongoing series where sometimes we cover just general or more generic simulation topics. For that, we usually have outside guests, academics and experts in the field. And sometimes we talk about things that are specific to ExtendSim. So this is one of the sessions that is specific to ExtendSim. We are recording this, so if you have to leave early or something happens, you'll be able to see this. It usually takes a week or two for us to get this up online, so give us a little bit of time to get that up there. Also helping me out today is Robin Clark, so he's going to be answering some questions. If you're new to the webinar series and the software we use, there is a questions box and you can type in questions. We do have everyone muted because right now, for example, we have over 20 people here, and the background noise gets to be a little overwhelming. So feel free to ask questions at any point, and I will stop and pause now and again to see if there are questions that I can answer. So with that, let's get started. Again, my name is Dave Krahl. I'm an engineer here at Imagine That, and I think I recognize many names here. Some of you I know only online, and some of you I know personally. So we're going to talk about ExtendSim and hierarchy today. I'm going to walk through a simple example and show you basically the kind of how you'd approach managing hierarchical blocks in ExtendSim. So it's going to be a little basic to start with. So if you're familiar with this, bear with me. I will try to go fairly quickly. If you want me to speed up or slow down, just post something in the question box saying I'm going too slowly or too quickly. So hierarchy, in fact, is an encapsulated model worksheet. So a hierarchical block is fairly self-contained and is independent of other hierarchical blocks for the most part in the model. And there's some big advantages to this. Things like named connections are local to that hierarchical block. And if you think about it, if they weren't local to the hierarchical block, then you couldn't duplicate hierarchical blocks. So the idea that a hierarchical block itself is kind of self-contained is very important to the fact that you can have multiple instances of the same hierarchical block and they can operate independently. But you can think of them as kind of an encapsulated model worksheet or a worksheet within a worksheet. So blocks and named connections are independent of each other. So each block contains the blocks or the library blocks contained within the hierarchical blocks, and these are all, in this case, you can see that I've got circles around the library blocks, the elemental blocks, and these can be also hierarchical blocks. So you can have hierarchical blocks within hierarchical blocks. A help, and I don't tend to use the help all that much myself, but I probably should more. So this is a handy way to add additional notation to the hierarchical block. An icon, and in this case we have not only the icon itself or a picture that's been pasted in, we also have some animation objects, and these are the dotted squares there where you can see this will show you interesting things happening inside of the hierarchical block on top of the icon, and you can specify what's going on there. Any connectors for the hierarchical block, and this is another thing I'd encourage you to utilize, is not just use our default names, but give them names that mean something. So in this case, I've used parts in and parts out. But it's really helpful for documentation of what's going on in the model. It just presents better that way. So why use hierarchy? Well, a big one is presentation. Every once in a while, we'll get a model in here where someone doesn't use hierarchy and they've got a couple thousand blocks all at one level. And it's really hard to kind of fathom or get an idea of what's going on there. So we have a general rule, and that is that every level of the model should be visible on one screen. So as whatever your monitor can show, you should be able to see the entire level of the model. And that works very well in terms of an organizational structure of the model. It helps when you want to explain it to someone, you don't have things running off the edge of the screen. Also animation. You can add your own animation to hierarchical blocks, your own icons. You can make it look much more like your own system. You can hide details of the model, and this is important, particularly if you want to show your model to other people. If you show them 2,000 blocks at once, they're just going to get overwhelmed. But if you say, okay, these are the basic processes, and then let's drill down and look at those in detail, that can be a very effective way to present a model. Also to organize the model so that you can control what sections of the model have what functionality. And you can create reusable components. So you can use hierarchy to create reusable blocks, and this is another good reason to use that. And we'll show an example of that here. So how do I create a hierarchical block? Well, there's two ways to do it. You can either select the blocks and then say make selection hierarchical, and this is the method I usually use to create hierarchical blocks, but you can also go to the model menu and say new hierarchical blocks. So if you're using the select blocks and then make selection hierarchical, this works well if you already have a section of the model that you want to turn into hierarchy, and that's typically the case. The connectors are created automatically for you, and one warning here is make sure you include exactly what you want, because there's no undo for this. So once you've said make selection hierarchical, if you didn't get that block or that connector either inside or outside of the hierarchical block, then you're going to have to go through a little more effort to readjust the model to make that come out right. Or one thing I recommend is just save the model, and then if you don't get what you want, you can always revert the model very quickly. So if you use the model new hierarchical block approach, the connectors must be added manually, and you add all the blocks to that hierarchical block. So let's go through that process very quickly here. Jump over to ExtendSim. Oops. So what I've got here is a very simple model. It has a database, and it's all kind of prepared, so you're not going to watch me do a lot of data entry. But I've got something that represents kind of a generic process. It's a machine that has a yield rate, and it's subject to failures every so often. So we have parts arriving. They wait in a queue. Then they're processed by the machine, and then there's some chance that they're tossed away based on a particular yield rate. And we're reading information for this particular machine from the database. So I have a database table with, in this case, 4 different machines. Each machine has its own processing time, time between failure, time to repair, yield rate. And what we're seeing is the results of a run. So we've got some results we'll be putting out there as well. Any questions? I see one. Let me see if I can answer it here. I have to rearrange my window a bit.
Dave, one of the questions that was up there was about getting data into and out of an H block. There's some of these questions, I don't know if now is an appropriate time or not, though.
Okay, yeah, I do see that. Yes, we'll talk about getting data in and out of an H block, and we'll do that with the database. So in this case, the database here is very important. Having this table of information is a good way to keep the information kind of outside of the hierarchical block so that you can create a scalable model. So that each block, in this case, is going to reference a different record in the database. And you can have them reference different records, which is most typical, but also different tables, and I suppose even different databases, although that's not something I've really used myself. So we'll see how that works. So I've got a model here. I'm reading the data, for example, the processing time, which feeds up here, the time between failure, the time to repair, the yield rate. All of these things are read from the database with the read block here and sent to the model itself. So I'm going to use my favorite method of creating a hierarchical block and select a range of blocks, and I'm going to be very careful about this. And you can see I've just got one input connector and one output connector. All of these named connections I want to be local within the hierarchical block. So if I leave one of those out, what that's going to do is make a connection on the top of the hierarchical block to the outside. So for example, if I wanted to report departures, I would unselect that, and then I would have a connection, a value connection coming out of the hierarchical block. But I want to keep that within the hierarchical block. Now you can always add and remove connectors later, so these things aren't set in stone. It's just handier to have them done up front. Then I right-click and say Make Selection Hierarchical or Make Hierarchical, and I'll call this a process. Okay, and then I say Make H block. So what that's done is that's turned all of that into a single block. Okay. So now how do we open the hierarchical block? Well, it's pretty obvious. One way to do that is just to double click, and that reveals the contents of the hierarchical block. And you can make changes to the block, set parameters, and this works very well where you have just a hierarchical block that's just kind of in isolation. You're not replicating the same hierarchical block in the model. You're not particularly concerned what the icon looks like. You're not adding animation to it or help or anything like that. Another approach is to open the structure of the hierarchical block, and this gives you an editor that you can use to edit the help, the icon, and the connectors, and it allows you to make changes to the blocks inside of the hierarchical block as well, but also the help, the icon, and all those sort of things. So let's take a look at those two methods. So if I double click on the hierarchical block, then I can see what's going on here. It's just what we're just looking at is the sub model worksheet in this case in that sense. Now, if I close this and I right click and say open structure, this gives me more tools in terms of editing the hierarchical block. So now I can type in my online help, which says this represents a process. And I can go on and type as much as I want there. I can rename my connectors here as well. So I may have parts in. And one tip about the connectors is input connectors always have to end with in and output connectors always have to end with out. So your connectors either will end with in or out. There are no other options. So I have parts in here. And in this case, it doesn't make a whole lot of difference because I've only got one input connector and one output connector. But if I had a more complicated hierarchical block with many connectors, it can be invaluable in keeping track of where the connectors are, is to label them well. Now, another thing I can do from this editor is modify the icon. So let's take a look at that. I've got a little picture of a machine here, so I'm going to take that and copy it. And this came in, I think, from Microsoft Word or the internet or somewhere, I forget where now. But you can copy pictures in from a variety of sources. And I'll go back to my editor and paste my picture in there. Delete my old box. And I'll move the connectors to convenient spots on there. And it kind of helps to move it up into the corner so it's easier to edit up there. So now I've edited my hierarchical block. I've added help so that if someone else looking at the block, or even myself at some point in the future, can tell what this block is supposed to do. I'd recommend something a little more descriptive than what I've got here, but that gives you the idea of it. I can see the blocks or the contents of the hierarchical block. I've renamed my connectors here. I might slide that in a little bit. And I've got a new icon so that my hierarchical block will look something like what I'm actually modeling. And I think I'm in good shape here. So I'm going to close this, and it's going to say save to this block only, so I'll save that. And now I've got my machine block here. And I don't need my picture anymore, so I'll just remove that from the model. Okay. Let's go back to our presentation. So we did this. We added a new icon. So one way to do it is to use ExtendSim's drawing tools. And I'm not really going to cover that here, but we've got some basic drawing tools where you can draw circles and squares and polygons and that sort of thing. Or you can paste in an icon from an external source. So you can actually do what I did and take something outside and bring it in. And that's the most typical way to create icons. I've seen a number of people use pictures of actual equipment, and that can be effective for a presentation as well. We can also add animation objects to the icon, and this is done with the icon tools menu. So that's a little square up there that looks like a connector on the menu, and then you go down and select animation object. So you click on the icon tools in the toolbar, select the animation object, and draw the animation object on the icon. You get a little square with a number in it, and each square will have a unique number in there. So it starts at 1, the next one is 2, 3, 4. And then you can reference that from the blocks to create animation objects. Now, one trick I use is I create one of these, for example, if I want to show the contents of a queue, and then I just copy and paste it to get a number out there that are the same size in the icon, so I don't have to add them one at a time, and that could save quite a bit of time. So let's add some animation objects to our block. I'm going to open up the structure again, so if I'm going back to right-click, open structure, and I'm going to add some animation objects here. So I go to the icon tools menu, and all the way to the bottom is an animation object. So some of the things I would want to show here, for example, I want to show when the machine is busy. So in my little display here, I'm going to add an animation icon, and that will show whatever product we're working on right now. Kind of slide that around a little bit. And I can move it around and I can resize it with this little handle down there in the corner. And then I might want to show when my machine is down. So that's going to be quite simple. So I'm just quite similar to this. So I'm going to duplicate this and add another one. So then my machine will be down. It will look like that. Or I'll have an image in that spot. And then I want to show the number of arrivals and departures. So I'm going to duplicate that again, but I want that to be a little smaller, and I want the arrivals to be up here. If I duplicate, I want my departures to be over here. So I'm going to animate what's currently processing in the animation object 1. I'm going to animate whether the machine is down or not in animation object 2, the number of arrivals in animation object 3, and the number of departures in animation object 4. And then I want to show the number of objects waiting here. So to do that, I'll create a number of animation objects that are sequential. And I'll duplicate that. Then you're not going to see this, but I'm going to use the Control D to save a little time and duplicate those again. So I'm going to show the first 8 objects in the queue. And I'm just selecting these and duplicating them. And this will give me a little stack of items waiting outside the hierarchical block. Now, to make things actually happen on the hierarchy, we have to do something in the blocks inside of a hierarchical block. And some of these are just parameters that will change, and in some cases we need to add some additional blocks. So let's begin with the parameters that we need to change here. I said first we wanted to show the items processing in the activity. So in the activity itself, we go to the Item Animation tab, and I can say Animate HBlock Object, and notice we have object number 1 here. And that is going to be our item showing up on the hierarchical block. Now, there's a little trick to this. If I just put a 1 in here, it's going to show me the number of objects inside of that activity. So I'll see a number there, 1, 2, 3, 4, 5, whatever. Now, if I show 1 to 1, it's going to show the icon of what's there. And I could say 1 to 10. If I had an activity with a capacity of 10, I could show all 10 animation objects inside the activity on the hierarchical block. But I only have 1 there, so it's going to be Animate HBlock Object 1 to 1. Now the next thing I said we wanted to show was when the machine is shut down. And in that case, I'll need to have another block that shows that will animate a shutdown of the machine. So I'm going to use a block from the animation library. And I'm going to animate a value, and I'm going to look at the value of the shutdown block. So I'm using an animate value block, and I'm going to animate the value, the output of the shutdown block. And in that case, I'm going to show a picture, and I've added another picture, actually just dropping the picture into the extensions folder. So I've got a sad computer here, and you can see a little preview of that. And I don't want to delay the simulation, so I'll turn that off. So whenever our machine is shut down, our input is greater than 0.5, I'm going to show this little sad face saying that I'm shut down. And that is going to show an animation object number 2. So that 2 here corresponds with the 2 here. Then I also want to show my arrivals and departures. So I'll just duplicate this. and I'm going to show not a picture, but a value in animation object 3. And I'll duplicate that. And then this will be departures in animation object 4. So conveniently, I have arrivals here. And I'll connect this up. So what this is saying now is in animation object 3, I'm going to show the number of items that have arrived. And in animation object 4, I'm going to take my departures and duplicate that. And I'll show the number of items that have left. I've got one more thing left to do, and that's animating the contents of the queue, and that works very much like the activity. I go to the Animation tab, and I'm going to animate objects. In this case, I'm going to start at 5 and go to 12. So from 5 to 12. Now you might ask, what's going to happen if I have more than 8 items in the queue? They just won't show up. So I do have to have an animation object for every item that I want to show. Any questions based on the animation there? Okay, I'm not seeing anything new. So we'll save that block. And let's run this with animation so we can see if everything is working correctly. You can see our block, that looks pretty good. We're not seeing any downtimes yet, but that will probably occur at some point here. I didn't change the original animation object, so we've got little green balls flowing through the process.
Yeah, Dave. So if we had an animation in the create block, would it still show up as green balls with that animation, or would it change the animation there as well?
Let's do that. That's a good question, Robin. If we change our animation here, so we want our part, where's our part? Our gear, I think, is what we were animating. Now we'll see that showing up there. And if we had different animation pictures, we would see those. So if we had 2 different kinds of processes, now we're shut down right now, and you can see the queue kind of build up. So we had our sad face that our machine was shut down. So we've animated a hierarchical block. Now there's many more things you can do with that. In fact, you can get quite creative with it. You can even call animation functions within an equation block. So you can make things happen, displaying certain text, displaying levels, bar charts, that sort of thing. All of that's part of the animation, and you can do that on a hierarchical block using the very same techniques that I just showed you.
And so could you quickly go back once again and show us the animation blocks that was used as a quick review?
Okay. So this is how we animated what was going on in the hierarchical block. We are animating 5 different things. We're animating whether or not the machine is busy in animation object number 1, whether or not the machine is shut down in animation object number 2, the arrivals and departures in 3 and 4, and the length of the queue in 5 through 12. And to do that, showing the status of the machine or whether or not an object of the machine is worth showing, we go to the item animation tab on the activity, and we're saying show whatever's in this activity on animation objects 1 to 1. So this is actually showing a range of objects. In this case, it's just 1 to 1, and it will show the animation picture for whatever is in the activity on the icon of the hierarchical block. For the shutdown block, we don't have a built-in feature to show that whether or not it's shut down, so we're using an animate value block, and in this case, we're saying when the input is greater than 0.5, this will be when the machine is shut down, we're going to show a picture of a sad computer. Now, the sad computer is a picture I've added to ExtendSim. This is not one of the standard pictures. It's something that I saved in our pictures folder inside the extensions folder. So you can add your own pictures that way. For the arrivals and departures, they're really pretty much the same. It's just the arrivals we're showing on animation object 3, and we're taking the named connection, which is from the information block, which is the number of items that have arrived to this hierarchical block, and we're just going to display that value on the icon of the hierarchical block, and we'll do the same thing with the departures. So in this case, we're looking at animation object 3, and that ties into this animation object 3 over there. And then animating the queue contents is just like the activity. But in this case, instead of showing just one object, we're showing a total of 8. So from objects 5 to 12, we're going to show the animating the contents of the queue.
And Dave, the animate value block, the custom picture that you put in there, what file format does that have to be?
Oh, that's a BMP or WMF file format.
Great. Thanks, Dave.
So as we saw, each new animation object has a new sequential ID, so we can see what's going on here. So what I would be showing here is each object is a unique ID. So as I add the first one, I get a number 1, the second one number 2, and so on and so forth. So I've done a lot of work to create this hierarchical block. One thing I can do in ExtendSim is save it to a library so I can reuse it in the same or other models. And then there are tools for managing this so that you can update it. So when I save the block, I would open the structure of the hierarchical block, select Save to the library, and then I can update any blocks that are based on the same library block in open models. So let's take a look at that. And before I do that, I'll add my one more animation object, which was the number that I've thrown away here. So I'll just take this and I'll duplicate that again. So that's our trash bin. And I will add in here, I'll animate object number 13 in the exit block. So this is just going to show the number that I've exited. Okay. So now I can open the structure and I can say save block to library as. So I'll create a new library and I'll call it machines. So to do that, I clicked on the new library button here and I just label that machines. And that creates a new library file, and I'll install this in that library. So now I have a machines library. So if I open up my library window, I have my process block, and you can see the icon there for that. Now if I close this, it gives me some options. It says I can save to just this block, so only this particular instance will be updated. I can save it to the library, or I can update open models, blocks in open models. In this case, I've only got one instance of the block, so it really isn't going to matter much. So I'll just click on any one of those. Now I can take this block from the library, there's my machines library right there, take my process block, and I can drop down more blocks in the model. So now I've got 2 machines in my model, and they're identical. They're exactly the same. And I can put this in the same model or in other models. Now that leads us to the next slide here, which is managing the data. Remember I said they're identical. Now, I don't know about everyone else, but when I build models, I don't often have identical pieces of equipment, one following another. They may be very similar, but often the data between one and the next is going to change. And I may want to see results that are not just for one piece of equipment, but for all of the equipment in the model. So we have some tools for managing the data inside of a hierarchical block. And I did see there was a question about this, so I think I'm going to cover this question now. So when a hierarchical block is updated from a library, it is essentially re-added to the model. And that's a very important concept. What we're doing here is when we say update to from the library, what it's doing is taking away the existing block and reinserting a new one. So that means that any data that was associated with a hierarchical block, so if you have different data in one hierarchical block versus another one, it's going to be rewritten or written over by the block that was saved to the library. And there are many cases where we want almost all the data, but a few things we want to change. So in our example here, the things we might want unique to each instance of our machine block. So in this case, what we would want is to have a different processing time time between failures, time to repair, time and yield rate for each machine in our process. And we could have any parameters basically be unique to a hierarchical block just by setting it up this way. Also, we'd want to report some results like maybe throughput and utilization for each machine. Now, if you remember, we have a database here that's all set up with one record per machine. So we're set up for up to 4 machines in our model. And we have inside of our hierarchical block, we're reading the values from that database. But in this case, we're just reading it from record number 1. And we're writing values out to record number 1. So each block right now is identical. We're all reading and writing to the same place in the database. And that's probably not quite what we want. What we want is to use some tools to make each hierarchical block have a unique bit of information that's associated with that instance of the block. And there are actually 2 blocks that can do that. One is the constant block and the other one is the pop-up block. And they use the same mechanism to do it, but they each save a value that can be used to reference something outside of the hierarchical block. And the most convenient thing for this is the database. So let's look at these blocks and what how they work. If I open the structure of my hierarchical block, I can add, let's start with a constant block. That's in the value library. Constant. And it has a checkbox here that says retain constant if updated from hierarchy. If I check this, whenever I update the blocks from a hierarchical block from a library, it's going to keep whatever value I had on the constant block for each instance of that. So I might have values 1 through 10 for 10 different hierarchical blocks. When I update from the hierarchy, all the other blocks inside of the hierarchical block will be identical, except the constant block will retain its original value. So let's try that out. Let's say for our first machine here, I want to have record 1. So I say I'm pointing at record 1 here for my first machine. And I'm going to say retain the value if updated from the hierarchy. So I'm going to do this as a 2-step process. The first thing I'm going to do is save it to the library so I get that block in both hierarchical blocks. So I'm going to update all the blocks in the open model. And if I look over here now, I've got my constant block. But this one I want to reference record number 2. So notice I've got the output of the constant block connected to the record connector on the read and the write blocks. So this, my second machine is record number 2. My first machine is record number 1. Now let's say I'm going to change something else in the hierarchical block. Let me just kind of move these around a little bit. And I'll label this record number. And now when I update, oops, should open the structure. Update blocks and open models, we'll see that this kept its 2 and this kept its 1. So now I've got a bit of information that I can use to reference unique information in hierarchical blocks. In this case, it works very well for referencing information in the database. I'm saying I've got record number 2 in the first hierarchical block and record number 1 in the first hierarchical block and record number 2 in the second hierarchical block. Well, there's an even slicker way to do this. If I open the structure of the block again and I take out my constant block, and I'm going to use a pop-up block. So this is in the utilities library. And it has the same option. So it says retain pop-up if updated from hierarchy. Same option as the constant block. But now I can actually create a pop-up menu that allows me to choose which machine I'm talking about. So here's a trick. I can link my pop-up table. So you can either just put in numbers, text here as parameters, or I can link it to a database table. And I've got one database and one table, which is handy in this case. And now I've got my machines as the pop-up. so I can pick which machine this references. And I can also say, well, let's set the enclosing hierarchical block label to the pop-up so I can see what machine this hierarchical block represents. And I'll connect it up much in the same way. So now I'm picking machine A, machine B, machine C, or machine D from a pop-up. And one other thing I might want to do here is just clone this out so I can easily change it right at the top of the block. And what this is doing is it's changing what record in the database that I'm using for my information for the processing time, the time between failure, the time to repair, the yield rate, and where I'm reporting my utilization, the proportion of time I'm down, and the number of departures from this hierarchical block. So I'll update the blocks in the open model. Now, because this block did not have the pop-up block before, it doesn't have any value there. But I can select machine B, and it's set machine B in the as the block label. So I've got machine A and machine B. So if I update one, then the other one will retain its information from the pop-up. Then I can repeat this out a couple more times. Just duplicate these two. Add a named connection here. So I have my 4 machines in line here. I've got 2 machine A's and 2 machine B's. I don't really want that. Probably want a machine C and a machine D. So just by knowing how to use this pop-up block along with the read and write blocks in the database, we can now create a very easy to use, reusable hierarchical block. And let's watch this run just for fun, and I'll open up the database as well so we can see all of our values change. Let me just arrange my screen a little bit here. And turn on the animation. Animation's on. Speed it up a bit. So we can see things going down. We can see our machines going down from time to time. We can see our database getting updated as the simulation runs.
So Dave, I have a question for you.
Mm-hmm.
So do you put that constant block or pop-up block in every H block that you build? Or could you walk us through that concept again of why we would do that?
Okay. Let me stop the simulation. So the pop-up blocks you would put in hierarchical blocks where you want to have multiple instances of the same hierarchical block, but you want different data for those hierarchical blocks. And most of the information those hierarchical blocks realize is going to be the same. I want the same, for example, information about the animation objects. That's going to be the same in all the hierarchical blocks. And if I change something in one of those hierarchical blocks, I want that bit of information to change in all of them. But there's some information that is unique to each hierarchical block. And to track that unique information, the easiest way to do it is to put that in a database and use a constant or a pop-ups block to say, what record in the database am I going to use to retrieve that unique information? So in our database table here, we've got some unique information. We've got a machine name, which is unique for each hierarchical block, a processing time, a time between failure, a time to repair, a yield rate, and then we're reporting for each machine the utilization, the percentage of time it's down, and then the throughput rate.
So I see in the table that you had a yield rate of 100% for some of them and 90% for others.
Right.
So is that saying that 2 machines doesn't have any product failures, but you could still replicate it in here by just setting their yield rate to 100%?
Yes. Yes. So what we have there in those cases, like machine B, if we look that up, we can see our yield. Whoops. Must have been a different machine. It's machine D. Yeah, our yield rate is 1. So that means we only produce good products. So in this case, we do have a little extra going on. We don't really need that in this particular machine. But everything else is the same. So essentially, we're turning off a feature of that hierarchical block, that yield rate there. Okay, and that is contained in the database table. So if I open up our database table here, we can see our yield rate in that case is 1. Okay, let me... Okay. So there was a question there about how to get data in and out of a hierarchical block. The database is a great way to do that. There are some other tools, and I don't have as part of my prepared presentation, but you can also use throw and catch blocks. And I'm waiting for laughter from Robin on this, because we have different opinions about about the value of throw and catch blocks. But a throw block can throw a value, for example, outside of a hierarchical block. So let's say, for example, I want to see the sum of all the departures from my hierarchical blocks. So let's add that here. So I want to take one value and throw it to a central location. So I'm going to open my structure of this hierarchical block here, and I'm going to use a throw block. And before I finish connecting it up, I'm going to add a catch block, because throw and catch blocks always work in pairs. The throw block throws a value to the catch block, so I've got a catch value block here. And then let's plot out over time the number of items that have left each hierarchical block. So we're going to output the sum of all the values. I could define a catch group. I don't need to in this case. My initial output is going to be 0. That'll be fine. And I'll give this block we'll call it total departures. I'll give it a label. That makes it a little easier to work with. And then I've got a structure open here of one of these. So I say I'm going to broadcast to, I'm going to do a point-to-point. There's no group, to total departures. So this is going to send that departures value to one place. So this is a way of overriding the fact that in ExtendSim, all of these named connections are local to the hierarchical block. And like I said before, they have to be local. Otherwise, if they weren't local, then you couldn't duplicate a hierarchical block. It would just be a mess of values getting communicated to each other. So the throw and the catch blocks allow you to throw across the hierarchical block boundaries. And there are throw and catch blocks for the value library, like I'm using here. There are throw and catch blocks for the item library, so you can throw and catch items. And there are throw and catch blocks for the rate library, so you can throw and catch rate. So let's close that, and then we're going to update our blocks in open models. And if we look at that, we'll see now we've got these departures in all of our hierarchical blocks. And now as I run the model, I'll open up our plotter here. Let me change our auto scaling. So we can see this is all the items that have left all of the hierarchical blocks. Are there any other questions? I see a question. What is the best way to show changing values, added variances in a range for different components in a model? That's a good question. You could be quite creative with that. One way would be to use a bar chart to show values, maybe maximum, minimum. It's pretty flexible what we can show here. For example, I could add another animation object that maybe showed our utilization of our machine as a little bar here. So let's throw that in. So we got object number 14. And another animation object. And I'll take our utilization and duplicate that. So I'm taking our utilization and feeding that into an animation object here. And now instead of saying I'll display just the value here, I'm going to animate by changing a level. My minimum is 0, my maximum is 1, and make my color green. So this is one way of kind of showing what's going on in the simulation as well. Whoops, forgot to change one thing there. That needs to be 14. So if you notice what happened there, the animation, it was still set to animation object 3, so animation object 3 was going up and down. So this gives one sense of variation of the model. Another way to do that would be to write out values to the database. So whatever you want to capture in terms of showing variation in the model can be written to the database, and then you can examine it in plots in outside software such as Excel or Jump. There's also an error bars plotter so that you can see the variation over time along a certain value. So that's a little hard question to answer just in kind of an abstract sense. It's an easier one to answer if you start talking about a concrete sense. You know, I want to show the variation in throughput from one run to the next. Then we can come up with some good ways of representing that. Robin, do you have any more questions or comments?
Yes, there was one question about this. Are there any constructs that can't be done this way inside of the H block? And I think one example was brought up looking at some advanced features of the shutdown block, where the shutdown block is hooked up to a database table.
Yes. I'd have to think about, hold on one moment. That may or may not be able to be done. Let me see if that.
And my thought on that would be maybe you would have to take the shutdown block and bring it outside of the H block.
Yeah, if you've got multiple components repair, this is an advanced feature of the shutdown block. And what this allows you to do is have a database table with each record representing a particular component in the table. And I'm not sure you can't do it. It would certainly be more work to do it. But you'd select a database, a table, an ID field, and a time to repair field. What we could do is play some tricks and change these parameters here when we update the hierarchical block. So each hierarchical block in this case will be looking at a different table. It might take an equation block or something to set that up at the start of the simulation. So there are things that I'm fairly certain there's some things that would be that you couldn't do. This may or may not be one of those. I'd have to think about it for a little bit. But this would be an example of something that would certainly be a little harder to do because really what you've got is instead of just a record per shutdown, you've got multiple records for each shutdown. So you'd have to kind of scale up that way instead of thinking of a record per database per instance of the hierarchical block, then you'd have a table per instance of the hierarchical block. Now, the question, of course, if you can or can't, since we have, I'm just wondering if this has a table connector. No. One thing we could do is add, for example, or you could do, because you can get at the source code of the blocks, is add a table connector so that you would select which table you're actually referring to inside of the hierarchical block. Are there any other questions?
There was one other question, and on the animate value block, there is an option in there regarding the animation object is residing outside the H block icon. When would you ever use that
Well,
checkbox?
That has to do with refreshing, what the refresh looks like. So in this case, they're all kind of within that space of the block. So by leaving it unchecked, it will animate a little faster because it doesn't have to look to see where it's going to refresh. By unchecking it, if I were to move it outside of the footprint of the icon, and there are actually functions that move around the animation objects if you wanted to do that, that gives a little more rigorous refreshing. So most cases, what I would say is leave that unchecked unless you notice it's not refreshing right, and then check it, and then it'll probably fix any refresh problems. So as a practical matter, you probably just want to leave it unchecked unless it just doesn't look quite right. It's not going to make any difference in how the simulation behaves, and if the animation is off, it'll make no difference at all in anything.
Okay. And another question someone had is, could you show two pictures on the same animation object?
Not at the same time, but you could alternate between them. So I could have, for example, let me discard my changes. Let's say I now have two sources of creation of items. Oh, by the way, let me show you something else that's kind of neat. I'm using 9.1, which we just released this week, and it's got a nifty new feature here where I can right-click on an output connector, and it gives me the common blocks that are connected to this. So a select item in often follows a queue, so I can right-click there, and I can also do that on the input side and say I want to go back to a create, and it adds the block for me there. So I've got two different pictures. I've got two different types of parts. So in this case, that's got see, I've got a part bolt. So I'm making gears and bolts. And let me slow down my arrival rate here a little bit. And now we can see it's actually going to alternate between the different parts based on what's actually in the machine. But you can't show two pictures at the same time in the same object. You'd have to have two different animation objects.
I think what he might be referring to is where you have the sad face out.
Mm-hmm.
When it's running, show a happy face, and when it's off, show a sad face.
Oh, absolutely. Yeah. I don't think I have a happy face picture. But if we change that, that would be right here. I would need a different and then from the value library, a math, which would be a not. Oh, where are we? There we go. Not. Or in alphabetical order, but and so maybe I want to show a light bulb. So I'm operating well right now. So now when we run, we're all operating. We get the light bulb. And I guess I'm not seeing my sad face. That might be the way I've ordered those two. Let me reverse the order of them and see how that works. And then also, and I haven't gone into this because of time, we're about out of time right now, but you can also use equation blocks, and I think I mentioned that, to show what's going on in a hierarchy. Whoops.
And I think the guy, one of the questions was just kind of asking something about that, about could you show the level there with the utilization being red when it's below a certain level and green when it's above a certain level? Would you be able to do that with an equation?
Absolutely. Yeah, you can change the colors of these objects. You can change the shapes. And in fact, you can even use a rather nifty function we have called animation poly, which allows you to draw a shape mathematically. So you can describe the coordinates of the shape and then pass that to the animation object. So you can do that sort of thing. I'd have to fiddle. Yeah, there's our sad face. I'd have to fiddle with our happy face, sad face, and maybe I might need to do that with an equation block. I certainly could do that. Or you could build your own animation block. That's actually pretty straightforward to show multiple pictures. Well, I'm about out of time. I try to keep these sessions to an hour. Any more questions?
Lastly, Dave, someone asked if you'd be able to share this model.
Oh, absolutely. Yeah. Ask them to send an email to support@extendsim.com, and I will send it right out to them today. And I'll save it, in fact, right now so that it's done.
Thank you, Dave. I think we've taken care of all the questions.
Okay. Thank you very much. Looks like I've ended right about on time. We look forward to seeing you folks next month when you can learn about the satellite and communication models from Doug Shannon. And if anyone has any ideas or requests for future master classes, either specifically on ExtendSim features or on general purpose simulation concepts, please send an email to support@extendsim.com or call me directly at our main phone number, which you can find up on our website. And I'd be happy to entertain any of us. So thanks again, and I'm going to end the session now.